Do we really, at this point, need another UI paradigm? Isn't Windows Forms good enough? Well, the problem is that applications that are created using Windows Forms really don't show off very well these days. Applications now require a new way to present information rather than just using rectangular forms, charts, and graphics. I mean, to be honest, that figure represents an application that looks pretty good, I guess, but the problem is it looks so very 2005. In the current climate for building applications, people expect something that looks better than that. So what's wrong with what we have? Using Windows graphics techniques makes creating visually appealing applications pretty difficult. Up until recently, graphics hardware really wasn't powerful enough, in general, for anything more than Windows Forms. And in some computers, Windows Forms was pushing the capability of what the graphics could do in computers. You could create movie-style interfaces. I always think of the interfaces they use on TV shows and in movies. And I look at those and say, well, obviously they're not using the same tools I am to build those applications. You can do it using Windows Forms, but it's difficult. And each time you do it, you have to build your own set of tools to make it happen. 3D graphics are extremely difficult without some sort of external library. Windows Forms doesn't have much. And standard Windows GDI and user libraries were, to be nice, extremely limited. Windows Presentation Foundation, or WPF, provides a new medium for building client applications. WPF takes advantage of hardware power, and it provides a consistent, powerful graphics platform. If you look at what WPF gives you, it provides an integrated, vector-based composition engine, and it utilizes the power of the PC throughout the entire graphics stack. For simple forms, for video, for displaying motion, for 3D graphics, it handles it all for you. It also supplies resolution independence, so in general you don't have to worry about the resolution of the output display. It provides a unified approach to UI, to documents, and to presenting media. And the integration is part of the development experience. You end up with applications that might look something like the little graphics you see on the screen here. WPF also uses declarative programming. It brings designers directly into the application development because you separate the design and the code. As you'll see in our demonstrations, the design often has nothing to do with the code. You write code separately and hook them together. You can even use separate tools if you like, one tool for designers, another for developers. WPF supplies ease of deployment. It allows administrators to deploy and manage applications securely. Now, in terms of graphics, WPF includes modern graphics capabilities. It supports both 2D and 3D graphics, not 4D, maybe that'll come next year, just a little joke. And it supports image effects and multiple codecs for displaying audio and video. It supports hardware-accelerated sub-pixel clear type for very clear display of text. And of course, it has full audio and video support for many different formats. Now you probably have some questions. First of all, does WPF allow me to do something I couldn't do before? And the answer is, for the most part, no. It's just about the amount of work you want to put into getting the results you need. Windows Forms makes pretty much anything complicated difficult. On the other hand, WPF makes some of those same things much easier. I'm writing a game. Should I use WPF instead of DirectX? And the answer is, that depends. For hardcore games that require, well, hardcore graphics, DirectX might be a better choice. But you can combine WPF and DirectX together in the same application. Should I drop Windows Forms now and use WPF instead? And again, that's debatable for ordinary business applications. Visual Studio provides a similar set of controls for each, and there are third-party controls for each that give very similar functionality. WPF, however, makes it far easier to create rich, media-centric applications. If you're just typing in names and addresses, Windows Forms probably will do. On the other hand, if, and I hope you don't, if you need Windows 98 support in your application, Windows Forms are the only choice because WPF doesn't support Windows 98. Boo-hoo. Should I use WPF instead of Adobe Flash? Another good question. Thank you. For web-based applications, Flash is currently a pretty strong standard for media. Silverlight provides a very small WPF-like runtime that supports the same declarative markup as WPF and JavaScript, and you might find that better for browser-based applications. WPF supports browser-based applications as well, but that's a little outside the scope of what we're talking about in this course. In any case, you'll need to think hard about whether it's time now to adopt this modern platform, WPF, or stick with Windows Forms. Of course, if you've gotten this far, I'm assuming you're sort of interested in WPF, and we'll go on with that assumption. Of course, Microsoft provides two technologies for client-side applications, WPF and Silverlight. You might think that Silverlight is a web-based technology, and it is because it's hosted on a web page, but it's actually a client-side technology because it runs on the client. Both technologies allow you to create client applications, and both use XAML, that's a grammar of XML used to define the markup, to design the interface. WPF, on one hand, has the entire .NET framework behind it. You can use anything in the .NET framework, well, as long as it applies to WPF. On the other hand, Silverlight works only with a small subset of the .NET framework. And sometimes, as you build Silverlight applications, you will be shocked at the tininess of that small subset. Things you were sure would work don't in Silverlight because they aren't supported in the subset of the framework that's included in the downloadable runtime for Silverlight. WPF ships as part of the .NET framework, well, 3.0 and later. It runs as a Windows application, or as a web browser application called an XBAP, but it's still a Windows application running on the client. XBAPs run only in Internet Explorer with .NET 3.0, and both Internet Explorer and Firefox if you have .NET Framework 3.5 and later. But not every browser is supported for XBAPs. WPF runs only on Windows machines and only starting with Windows XP. It does provide the richest functionality possible, and it provides full support for 3D graphics. On the other hand, Silverlight ships independently. It isn't part of the .NET framework. It can be hosted only by web browsers. Internet Explorer works, Firefox, Safari, other browsers work. I'm sure. I have not tried them. I've tried all three of these. It runs on Windows, Mac, and Linux clients, and I've tried all three to make sure. And functionality is a subset of WPF's feature set. It uses only a small subset of the .NET framework, and like I mentioned, you will certainly be surprised sooner or later by how small that subset is. So which one of these do you use, WPF or Silverlight? It depends on your target audience, your technological needs, and your preferred deployment. Given all this information, you should be able to make an intelligent decision, but you'll have to think every time, should I use WPF or should I use Silverlight? And also keep in mind that over time, Silverlight's footprint keeps getting larger and it keeps getting more functionality. For example, Silverlight 4 includes support for COM interop in trusted applications, which means you can do almost anything in Silverlight 4 because of COM interop. You could talk to a Word application, for example, using COM interop, which you couldn't do before Silverlight 4. As in any new technology, there's always a few wrinkles. Here's some things to think about. It's far more difficult to create a decent-looking application using XAML, that is, the markup which we'll be studying, because the bar is so much lower in other environments. If you build a Windows Form application, no one expects it to look any better than a gray box with some controls on it. That's what people expect. Developers creating applications in XAML generally create ugly applications. Every application you'll see in this course, ugly. We're showing you the technology. We're not artists. We're not designers. We're not creating beautiful applications. Hopefully you'll have designers on hand to help you out. Good XAML applications require graphic designers. This is a fact. Unless you are extremely gifted graphically, your XAML applications, that is WPF or Silverlight, are gonna look, well, you can guess. On the other hand, it's far easier to create a great-looking application using these technologies because Windows and web forms without WPF or Silverlight are so limited. And I'll say it again. Do check out Microsoft Expression Studio because it will help you create a better-looking application because of its graphically oriented tools. People often think WPF and XAML are the same thing. Are they? Well, XAML is an XML-based grammar. It declaratively defines the user interface for WPF applications. Think about this. Windows Forms is a set of classes. You know, there's the form class, there are the control classes, there's a lot of classes defining the behavior of Windows Forms. WPF, too, is a set of classes, just like Windows Forms. For a Windows Forms application, you have to write code to generate the interface. You're saying, wait, no, I just drag and drop controls. Well, when you drag and drop controls, Visual Studio writes code for you. No matter how those things get there, someone is creating a variable that refers to an instance of a, say, button class, and someone's writing code to create an instance of the button class and assigning it to that variable, and then setting properties of that variable. That code has to get written somewhere. For WPF, that's not the case. For WPF, you can either write code, just like you did in Windows Forms, or you can create XAML. The difference is, when you use WPF, the designer doesn't write code, it generates XAML, XML markup, which defines the user interface. And then at compile time, the XAML compiler takes that XAML and converts it into bits that can be run by the .NET runtime. It's important to note that XAML and WPF is not a one-to-one mapping. Although there are many classes in WPF that have the same name as the corresponding elements within the XAML markup, there's no rule that says that has to happen. Some names in XAML don't exactly match the same or corresponding member names in WPF classes. You just need to be aware of this as you create your XAML, because sometimes you'll want to go look in the documentation for the class that corresponds to the element you've entered in your markup, and sometimes the names don't match exactly. In general, though, for every element you see in the XAML markup, you'll find a corresponding class in the .NET framework that's part of WPF that represents the behavior of that class. Visual Studio 2010 provides several project templates for WPF. You can create a simple WPF application, a WPF browser application. There's a WPF custom control library which allows you to use Windows Forms controls, or a WPF user control library which allows you to create new WPF controls. In this course, we'll focus on the WPF application template, a very simple template that includes a single window for creating one window of a WPF application. Of course, you can add more, but for our first demonstration, we'll just use the template as it is. So let's stop now, go to Visual Studio, and create our first WPF application. In Visual Studio 2010, I'd like to create a new WPF project. I find the simplest way to do that is by pressing Ctrl-Shift-N, which brings up the New Project dialog box. In the New Project dialog box, I'll choose Windows and choose WPF application. I find it interesting that Microsoft still lists Windows Forms as the first or default application template. You have to make effort to use WPF, but in any case, I'll create a project called WPF Intro and click OK. Once you've created the project, Visual Studio displays a XAML window and a layout design window. We don't need the other windows for now, so I'll close them. And you have some flexibility when working with these windows. You can, for example, if you have a widescreen monitor, switch to vertical layout, or you can switch back to horizontal for taller monitors. And it also is interesting to note, though I can't demonstrate it here, that Visual Studio 2010 very nicely supports multiple monitors, so you can drag the Properties window onto a second monitor if you want, and then split your display vertically on a widescreen monitor. Makes it great for developing WPF applications. You can also swap the design and XAML locations. Maybe you want the XAML on top and the design on the bottom. That's up to you. You may also decide you want to zoom in or out on the layout window, and you can do that using this slider here. For a very small view or a very close-in view, you can use that slider. Now, when you create the project, Visual Studio puts some XAML markup into the XAML window for you. And you need to know what that stuff is doing. First of all, we have a window element that defines our main window. We have a grid inside of it. That grid element acts as a container for the other controls in your application, and although the grid is helpful, it gives you rows and column layout, you don't have to use it. You can delete the grid and put something else there, or have no container at all. Just have some controls there. You'll also see inside the window element some attributes that define its behavior. We have title, height, and width, which say we want this window to be exactly this height and width with this title, but there are also a couple of namespaces defined. We have a default namespace, which is this, and it doesn't really matter to me what that namespace is, but it does matter to the XAML compiler. That's the default namespace, which indicates for any element which doesn't include a prefix, that's the namespace it is in. A namespace acts as a categorization for elements. So grid, since it doesn't have a prefix, belongs to this namespace. And this allows the XAML compiler to take XML in the XAML markup and map it to classes in the .NET framework. That namespace says, when you want to find something in this namespace, go look in this clump of .NET Framework classes. Doesn't matter to you what that clump is, but it does matter to .NET. There's also a second namespace with the prefix of X, and everything in that namespace, including this attribute, for example, belongs in this namespace and maps to a different set of .NET Framework classes. And since this one ends with presentation and this one doesn't, it should be pretty clear that this stuff deals with UI, and you wouldn't know it, but it's true, this stuff deals with code. This attribute indicates the name of the code behind class for this window. So whenever we want to write code, it'll be in a class called WPF intro.mainWindow, and the compiler will know where to look for that code because this attribute tells it. Much like those mattress labels you see on mattresses when you buy mattresses would say, do not remove this tag under penalty of law, you better not remove any of this information, the namespaces or that class attribute, or your code won't work. Unlike the mattress where you can cut that tag off once you get home, although I never knew that as a child, you can't remove these or the code won't work. Let's modify some properties of this thing. To do that, I'll go to the Properties window, which is over here on the right. Notice, first of all, that the window, by default, has no name. It could have a name, but it doesn't. That's because in WPF, elements don't have to have a name unless you intend to interact with them in code. In this case, I'm not going to interact with this window in code. There's no reason to have a name attribute set for it. I would like to modify the title, though. I could modify the title here, or I can come over here and do it. You can see title is already highlighted, but if I couldn't find it, I can just type enough of the name here into the search box to bring it up in the Properties window. I'm filtering as I type. And here, I know where it is now. I'll delete that text. I'll come change this to be Hello WPF. And you can see as soon as I enter that, it modifies the title here in the markup and in the window. If I come back and change it in the markup, removing the comma, it also changes it in the Properties window and in the Layout window. So it's a two-way street for all these property settings. On the left, I have a Toolbox window. And here you'll find Common WPF controls and All WPF controls. These are the ones you're most likely to use. Down here we have all of them, and there are a lot. I'd like to play with a button, so I'll drag a button onto my design surface. Here you can see it looks different than what you might be expecting from your Windows Forms experience. It has a little arrow pointing to the left and to the top, and what we've set here is a number of attributes about that button control. I've reformatted the attributes. You can see what they look like. We have a content attribute which indicates the text within the button, and of course I can change that right here if I like, and it changes in the layout and in the properties window. We have a height attribute which defines its height, a horizontal alignment which can be left or center or right or stretch. Let me make it be center. How come it doesn't look centered? That's very strange. It says to center it. Well, the problem is we also have a margin attribute which says the left margin of this thing is 228 units from the left of its parent, which is the only cell in the grid right now. And so it can't center to the middle because it has a left margin of 228. On the other hand, if I make that margin be 0, now since I've asked it to center, it does actually center. By default, Visual Studio does supply a name attribute because they figure for a button you're going to want to write some code, so it needs a name property. There's a vertical alignment set to top, and you're asking, well, why isn't it at the top then? It's not at the top because there's a margin of 67 units from the top from when I dragged it on. If I set that to 0, it does now hug the top of the parent of the button. And there's a width property as well. Now you can set properties in the Properties window or in the XAML Designer. I must confess I've gotten used to doing it in the markup, so I tend to type XAML a lot. I have a lot of friends who do the same thing. You may find it more convenient to set properties in the Properties window, but there are so many of them, I find the IntelliSense more helpful than searching the Properties window. But it's up to you. If you want to change the name of the button, you can do it here, but it's also pulled out and exposed up here at the top of the Properties window, making it easier to work with. I'll change this to Demo Button, just to prove a point. When I leave that property, it updates here as well. Let's resize the button. If I click one of the sizing handles, you'll see that the display indicates the current size of the button, and down here, the markup updates as well to match. The margin property is interesting. Let's say just for kicks, I set this to 0, 0, 0, 0. And now we have a margin of nothing, supposedly, yet this thing still doesn't fill the whole container. You would think it would. Well, it can't because we have the height set. Well, let's delete the height attribute. Okay, but now it's just tall enough for the text. Why is that? Because vertical alignment is set to top. Well, let's delete that and see what happens. Now it stretches because the default vertical alignment is stretch. If you don't specify it, that's what it does. How come it doesn't fill the entire width? Because the width is 155. If I delete the width, now it's just wide enough for the text, because that's the default for width. If I modify horizontal alignment, though, so it's not centered, it will instead fill the entire container. So what you see here is the minimum amount of content that you can use to get this layout. Well, not quite, because the default for the margin is 0. And actually, if I specify just one coordinate, it uses it for all 4 sides. And if I put nothing at all, it assumes I want a margin of 0. So nothing changes. This is actually the minimum markup I can use to get the behavior that I wanted. That is a content that says click me and a name that is Demo Button. I personally like and enjoy, there's a challenge in this, coming up with the minimal amount of markup I can have and still get the behavior I want. There are some times when this obfuscates what's actually going on, so sometimes I add back in some markup to be explicit. But whenever possible, I keep things as simple as possible. Let me put the vertical alignment property back in here so we can try something. Vertical alignment, see, the IntelliSense helps me type. Now watch, I'm just going to press Tab at this point. When I press Tab, Visual Studio fills in the rest of the attribute and gives me IntelliSense for the possible values for this attribute if possible. Well, I'll choose at this point, say, top. And so now this thing aligns to the top. Let's say I want to modify this in the Properties window. How do I find it? Again, the easiest way is just type enough to identify or filter the list to vertical alignment, or here we have vertical content alignment as well. There's two properties that match that text. I wanted to show off this little glyph over here, this little icon. You can see the value source for this property is local, as opposed to this one, which is inherited. We haven't touched this attribute, so it gets its value from its parent. This one is set to be local. I can also click it, and now I have the option to reset value. I didn't right-click, I just click with the left mouse button. It's an easy way to reset the value back to its previous value, which in this case is nothing at all. No value set at all. So you'll find that this little icon or glyph here allows you to work with the property value. And we'll use that as we investigate and build applications. How about adding a little bit of code? Well, just like in Windows Forms, I can double-click on this button, and it creates the default event handler for me. I'll put some code in here. Messagebox.show hello from WPF. How does this hook up? Well, let's go back to our code, and you'll see that we've added a click attribute here, which indicates which procedure should be run when we click the button, that is, when the click event occurs. And if I run this, you will probably not be surprised to find out that, yay, it works. Okay, well, let's do a little more investigation here. Let me delete this and try typing click myself. When I type click, I get two options here, new event handler or demo button underscore click. So the IntelliSense looks at your code for any procedure which matches the required delegate type for this event and offers it as an option. I could choose demo button click, or I could choose new event handler. If I choose new event handler, it creates a name for new event handler, but doesn't create the code yet. I can right click, choose navigate to event handler, and it takes me to that event handler, which I really don't want. So I'm going to delete it, go back out to our code, here, delete this, and try again. Press equals, and this time I'll choose demo button underscore click, just like before. So now you've seen a couple ways to create event handlers. It's also interesting to note that if I look at the events for this button in the Properties window, you'll see the click event is already filled in. If there was more than one procedure that could satisfy this event, I could choose it from this list here. Visual Studio provides some other useful tools for working with WPF as well. You'll want to know about these. If I right-click in the Designer, I get an option to show the Document Outline window. Although our application isn't very complicated right now, they get very complicated very fast. And the Document Outline window allows you to drill into the hierarchy of controls in your application and see them in a document outline. You also see a preview of the control here, so it makes it easier to find and select any particular control in the hierarchy of controls. In addition, down here at the bottom is a tag navigator that helps you get to a particular tag. You can imagine the markup gets pretty long very quickly. So here I can select the window element, can expand it to any of its children. This only has one child. There's the grid. Can expand that to look at the button within that grid. And each time I select the corresponding tag. You'll find those two tools, the Document Outline window and the Tag Navigator, to be really helpful as you build complicated WPF applications. Now if we go look at the code that we just created, View Code, you'll see there's this class, Routed Event Args, which provides information that Windows applications didn't, and that's for a very good reason. If I look at that class, we'll see there is a handled property, original source, routed event, and source property. What are those properties there for? Well, WPF supports bubbling and routing of events. This button exists within a grid, which exists within a window. If we don't handle the click here at the button level, the grid will try to handle it. If the grid doesn't handle it, the window will try to handle it. If nobody handles it, no code runs. But you can handle this event at any level. And here, the handled property lets us indicate to any parent that we've already handled it and they shouldn't. There's also an original source property, which indicates the original source of the event. In this case, we're in the button's event handler, and the original source is the button because it's what caused the event to occur. But if we were handling this at a higher level, the original source would still be the button, even if we had changed what the source property is. You see down here we have a source property. We can alter that to fake parent containers into thinking something else triggered the event. This gives you very strong flexibility in your event handlers. Down here we have the routed event, and that is the event that triggered this event handler to run. And again, you can alter that, pass it back up to a parent, and make them think that a key wasn't pressed. You can make them think that the user clicked a mouse or something. You can alter what the event looks like to the parent. In any case, we're not going to use that right here, but we are going to try bubbling events. Let's go back to our designer. And here, let me modify this thing so it no longer takes up the entire window by setting the width equal, and watch what happens. I type width equals, and the designer puts the quotes in for me. You have to get used to just taking your hands off the keyboard. I'll type height, and I won't even finish it. I'll just type HEI, I'll press tab, and the designer puts in the equals and the quotes, and I'll type 100. There's our button. Let's move it out of the way. And of course, doing that sets the margin property for that button. Okay, I'd like to make a copy of this button, so I have two. I will right-click, choose Copy. I will right-click and choose Paste. Now I have two of them. And notice that the second button doesn't have a click event handler defined for it. Copying and pasting doesn't carry events along with it because most of the time that's not what you want to do. So right now, if I ran this, clicking this button would trigger the message box, clicking this one would not. I think you believe me on that. I'd like to add a window-level event handler for this. I can come up to the window and add button base.click, and that allows me to add an event handler for any control inside the window that inherits from the button base class, which the buttons do, of course. And let's come and see what the options are here. I can create a new event handler, or I can use demo button _ click because it's the same delegate type for the event. So I'll choose demo button _ click. What's going to happen now? If I run this thing and click this button, it has its own event handler, and it will bubble up to the parent because I didn't tell the parent that we'd already handled it. If I click this one, it doesn't have its own event handler, so it will only get the parent's click event handler. Let's try it. Let me save everything and run it. Click this, I see two message boxes. Click this one, I only see one. Well, although that does prove the point, it's pretty weird behavior. So if you're going to handle the event at the parent level, you probably won't handle it here at the button level, so I'll delete that. Now, how can I tell which button I clicked? My code might want to know that. Let me go to the code editor. And here, make use of the parameters passed to this procedure. Now in this case, I could use the sender, which is a button, cast it as a button, and retrieve its name property and use that. I'm going to use e.original source, just to show that this works. I need to cast this as a button, so I'll create a variable, and we will cast as a button e.original source. There we go. And now in this code, I'd like to call string.format, and here, rather than WPF, have a placeholder and pass in btn.name. There we are. Now, of course, we had to cast that control as the correct type, because otherwise it just thinks it's a control or an object. It doesn't know it's a button and that has a name property. So now it should tell us which button we clicked to get here. Let's save it and run it. This says hello from demo button. This says hello from button 1. So we have handled the event at the window level and managed to keep track of which control raised the event. At this point, I'm done with this code. So to clean this up, I'm going to delete this, go back out here and remove all the event handlers because I won't need them in the future.